Hi, welcome back to Math Maintenance. Today we're going to take a look at prime and composite numbers. So we've been looking at factors and talking about how we find factors of numbers and how we find multiples. When we're finding those things, when we find that a number has more than one and itself as factors, we have found what is called a composite number. So composite numbers are composed of lots of different pieces, or there's multiple ways that we can get to a composite number. For example, all even numbers are composite numbers because they have 2 as a factor of those numbers. Anything that has more than 1 in itself as factors make it a composite number. The opposite of being a composite number is being a prime number. So prime numbers happen when a number only has 1 and itself as factors. So for example, the number 5 is a prime number because I have 1 and 5 as the factors, and then there's no other ways to get to it using whole numbers, so it makes it prime. As you can imagine, prime numbers are far fewer than composite numbers because every even number in the world is a composite number. Any number that adds or ends in 5 we know is just visible by 5, so that's a composite number. And then we just really have to check our numbers with ending in 3, ending in 7, or ending in 9, or I guess 1. So 1, 3, 7, and 9 are the numbers that we have to pay a little bit of careful attention to when considering prime or composite. Today on the board I have some random numbers and I want to go through and figure out with you whether each one is prime or composite. We don't need to find all the factors of the number when thinking about prime or composite. We're just thinking about, does it have more than 1 in itself as factors? If we can think of any other way that we can get to that number, we know it's composite and we can move on. So let's start over here. 19. I know 1 and 19. Is there any other way to make 19? Well, it's not even, so I know 2 won't work. 3 times 6 is 18. 3 times 7 is 21, so that's too big. I think right off the bat we have found one of those elusive prime numbers. Remember I said they're rare and far between, but 19 is an example of one that is prime. Moving my way across the board, I get to 18. 1 and 18. Oh, 18 is an even number, so automatically I know it's composite because it's going to have a factor of 2. 17. It's not even, so that means I have to check some other things. I'm thinking 3. 3 times 6 is 18. 3 times 5 is 15. 4 times 4 is 16. 4 times 5 is 20. 5 times 3 is 15. 5 times 4 is 20. I've already looped back around. See, when I'm checking my factors, I already got to the point where I'm checking things that I've already checked by saying 4 times 5 and then 5 times 4. That means that I have found another elusive prime number. 6 is an even number, so without even thinking about it, I know that it's composite. 12 is another even number, so without even thinking about it, I know it's composite. 36 is an even number, so it's composite. 10 is an even number, so I know that it's composite. 31 is an odd number, so I have to check it a little bit more closely. 31, I can think of 3 times 10 gets me to 30. 3 times 11 gets me to 33. I'm running out of answers quick. 3, 4, 5 times 6 gets me to 30. 5, 6, 7. 7 times 4 gets me to 28. 7 times 5 gets me to 35. 7 times 5 gets me to 35. That means that 35 is a composite number. But 31, I'm striking out on. I'm thinking that it's prime. 42 is an even number, so I know that means it's composite. And 27, I would have to check because it's an odd number. So I know it doesn't divide by 2, but when I check dividing by 3, 3 times 9 gets me to 27. As you can see, even in my random assortment of numbers on the board, there are more more composite numbers than there are prime. And part of the reason for that is just because every even number automatically gets to be composite, as well as every number that ends in a 5. So that collects a lot of the numbers as we think about our hundreds chart. In your packet today is a page that looks like this. It says prime and composite number sort. All you're going to do is take a look at the numbers in the number bank and write them into the bucket that you think they belong in. Your digital activity today is actually pretty fun. It shows two numbers kind of on a balanced ball stick system. And what you're trying to do is to save the prime number. So first you need to determine which of the numbers in the system is prime and which is composite. And then you need to remove pieces of the system to have the composite piece fall away and the prime piece stay in place. The first level or two are pretty easy, but once I started getting up there in levels, it becomes a bit more challenging. First to figure out prime or composite, and then to figure out what pieces to remove to make the correct pieces fall away. Your manipulative activity today is to cut apart the cards in your prime composite deck. There are also pieces for prime and composite, little headers for those. Once you have those headers cut out, you're going to sort your cards, and then you can use the QR code on the header, scan it using your computer, hold it up to the little webcam, and go on the QR code scanner. And then it will pull up for you a list of numbers that you should have sorted. So cut out your pieces, sort your cards. Once they're sorted and you think you have it right, scan the QR code and it will tell you if you scan prime, these are the numbers that you should have in that pile. If you scan composite, these are the numbers that you should have in that pile. So it kind of allows you to self-check your work. Best of luck figuring out prime and composite. Remember some of those rules that we talked about. Evens are always composite. Things that end in 5 are always composite. And then it's really just those numbers that end in 3, 7, 9, and 1 that you have to pay a little bit closer attention to. Good luck.